field service engineer for Sunamp. Just before we start, we're trying a different format today through the means of this webinar. So yes, there may be some technical issues, but please bear with us and we'll get through it. We'll get through it, hopefully. So give me 1 second. I just need to send a test email off here. So yes, we're going to be starting off the training module 1. So it's for the Thermino ePlus. This is the direct cylinder replacement. All right. So I don't know if anyone's worked with the heat batteries before, or they need this course to sort of learn a bit more about them, or you're just curious for future jobs that may be coming up. So hopefully you can put your thoughts into the chat, and then Sarah and Philippa can sort of collate your thoughts so we can have a chat about it at the end of each session. So let's get started. So we've got a couple of house rules just about the webinar. Like I say, it's the first time we're doing it in this format, so please accept our apologies for any technical issues that may arise. But if you have any questions, please put it in the chat and we'll answer the questions at the end of each session. Messages in the private chat can only be seen by the webinar organisers. The public chat can be seen by all attendees. All webinar attendees are on mute by default. If you'd like to speak, please click the raise hand button. One of the webinar organisers will invite you to the stage, and you need to give permission for your camera and microphone, and then accept the invitation. We're not going to have the polls and everything. Just again, this is the first time we're doing this, but we do have some sort of questions that hopefully you can answer at the end of each kind of section of the presentation, and hopefully we can take from there. So just to let everybody know, I can't see this. I can only see my presenting screen. Okay, so I can't see everyone else. So that's the first technical issue. So yes, the webinar will be recording. So we can hand this out to other people. So if that's okay with yourselves, way back when as well. But she pioneered the first heat batteries, and which include our phase change material, which is similar to the ones that we.
Okay.
Then that's when before we sort of move on, in case you want to come to the floor and ask it directly to the group. Are we getting anything, Sarah? Engineer with our unvented ticket. So yeah, for the direct models anyway, if you're within direct models, you're probably just going to have your gas engineer or your heat pump engineer come out and service the appliance. And if there's a problem, they're meant to check the unvented side of things by checking the temp pressure relief valves opening up, and it's all fitted correctly anyway. So they'll just add that into the cost of the service for their time. But when you look at, obviously that's a 210 litre cylinder and its comparable heat battery, that's a 210 Thermino. So you can see the difference in size immediately. All right. Obviously somebody's lagged their pipe work, so it's a good job. Whoever's done that. Well, we've got the 4 sizes here. So we've got the Thermino 70, the 150, the 210, and then the Thermino 300, which is our biggest domestic unit that we have. So a little bit of sort of Sunamp history as well. Before we changed to Thermino, the previous models that we had were called Unique. So Sunamp Uniques, if you ever come across them, their sizing was 3, 6, 9, and 12. All right, so if you ever come across that's comparable. But the reason for the change, because we're in direct competition with cylinders, so essentially we've got to say, okay, well, if you've got a 150 litre cylinder, that's the unit that you need there. You've got a 210 litre cylinder you want to replace, that's the unit that you need there. All right. So hot water, heat batteries versus your hot water cylinders. I mean, for a start, that's the size difference there. So we're half the size. That's a Thermino 300, so that's our biggest unit. So it's just over 1 metre tall. The footprint will stay the same, 365 wide, 575 deep. It's just the height that will change with each heat battery. So yeah, no mandatory maintenance required on the heat battery itself. It works with heat pumps, gas boilers, direct electric for direct models, solar PV for direct electrics, or a combination of both with indirect models, district heating as well. So you can have any heat source with that, but we can cover a bit of that next week, the second module. There's no certificate required, although, if from a customer confidence point of view, if they know you're an approved Sunamp installer, hopefully you can get yourself onto our installer map. And then if you're on that map, then that gives the customers confidence that you've at least been on the training and that you know what a heat battery is for a start. Fully recyclable at end of life, so the 50-year test cycle as well. So that's what that 40,000 cycles is. It equates to 50 years. 10-year warranty. So standard warranty is 2 years, but if the customer fills out their warranty form online, the element which is fitted here, the heat exchanger and the phase change material is extended a further 8 years. So a total of 10 years for the sort of the kind of engine, if you like, of the heat battery. Electrical components will stay as 2 years. Electrical components excluding the element, right? We've got very low risk of Legionella there, but we've got less than 15 litres in this cylinder. That's the cylinder in this heat battery. So because of that, we don't have to comply with Legionella, and plus with the heat requirements that we have, the heat that gets generated within the unit is taking us above 55, so there's no Legionella cycle required for that unit. I keep taking the slide out, but Andrew, he keeps sliding it back in. But to be fair to him, he started the company in 2005 after his previous business, and now from humble beginnings, we've got 60 plus staff, developed, design, manufacturing in the UK. We've got our service department, technical support. We're moving our heat batteries into different training centres across the country now as well. So I think the Northeast, Manchester, Portsmouth springs to mind. Obviously, warehouse. We've got our materials science team and R&D and our engineering department as well. So we're always working on a load of stuff. But from humble beginnings just outside of Edinburgh, we're now starting to distribute worldwide. So, and we've got OEMs in Europe that we're using. We've got our country managers in Italy, Germany now as well. And there's some projects happening as far afield as Australia and North America. I think we're opening up an office in Canada. We've got our office in America, and we've got OEMs in Chile as well. Interesting project in Guatemala, which we'll talk about later when we start going through the specification table. But it's just showing you where we've kind of grew from a concept to a kind of worldwide, hopefully worldwide brand. So some accreditations that go with our unit already, we've been out of the market a short amount of time. So we're the only certified PCM in the world with the RAL quality stamp of approval. Kiwa approved for a heat exchanger, and we've obviously got our energy label there. Last year we got the King's Award, so as a company, you've got to be quite proud of these achievements that you make. It's just adding another string to your bow that we're getting recognised out in the industry. So so we're doing well.
We've got a couple of questions in the chat, Stephen,
Yes.
if now's the time. So one on the warranty, someone's saying, so only the electrical components are covered for 2 years and the internal is covered for a further 8 years if it's filled in online. Is that right?
That's correct, yes. So in total, from date of installation If the warranty form's filled out that day from the customer, the element, the heat exchanger and the phase change material will have a warranty of 10 years. The electrical components will only be 2 years.
Great. And someone else is saying in the install docs it says 450 top clearance. What's that for? And someone else has said, I think that's enough room to take the top lid off and get access to the PCB. Yeah. And then just a follow-up question saying if it's been installed underneath stairs where there's an angle, is the full 450 required for like the whole surface of the heat battery?
I would say if as long as you've got so you've got your pipework at the back. So as long as you've got access to get your hands in there. I mean, the 450 is a guidance, so as somebody said there, it's to get your head in there to work on the electrics at the front of the unit. So, yeah, an angled staircase, you're going to be a 45 degree. It really just depends. And this is all part of the assessment. You've really got to kind of look at that as from the installer's point of view. Is this going to be workable? Once this unit's in place, can I work on this unit? There's no point. I mean, I've seen it many times with heat batteries and in a previous life with boilers and stuff as well. How do you access it? People build rooms around an appliance and you can't get access to them. So it's all about just kind of thinking about it during the specification of the job, really. But yeah, that's the 450. I mean, that's, if you think about that as well, 450 to a removable shelf or something above that would be fine. So you could have that removable shelf at, say, tight up to the top of the lid. As long as that shelf could come out to work on it, that's fine. But something fixed like a staircase or a fixed shelf in place, you've got to really kind of think about that one.
Makes sense. You might come on to this later, but someone's also asked, could this be installed in a cellar, and are the electronics protected from colder, damper air?
So, we're going to cover those sort of questions in the health and safety, but I'll answer it now and just say the unit has to be installed in a frost-free environment. So if you're going to install it in a cellar, cellars can be quite damp, risk of freezing, things like that. And then obviously you've got to consider the heat losses in a colder environment as well. So our heat losses are calculated in an ambient temperature of 20 degrees, which we'll talk about that a little bit more in the specification table. But when you're talking about outside, weatherproofed outhouses would probably be your best bet. But again, as long as they're insulated well enough.
Okay. And another couple of questions on the energy label. So someone's asked, does the energy guide label refer to the heat loss or the electric consumption? And someone else has asked, is it now C? It was A+.
So yes, so that's the energy, that's the heat loss aspect of it. So when you look at the direct models compared to the indirect models will have got the A+ badge, which is fine. But what we get penalised for is our element. So the way I kind of look at it is when the unit's charging up, and it's completely stupid because you could be charging up from PV, which is free, and it still comes under a C class. But once the unit's charged up, it then changes back to an A class. But we've always got to put down what the charging up rating is, and that could be getting charged up from PV or grid. It's still classes on a C. So the A class does refer to the thermal heat losses, yeah.
Okay, thanks. I think that's all in the chat for now.
Cool. So yeah, I'm not going to go over all these. There was name 2 cylinder disadvantages. There's quite a lot there. So hopefully you were listening. But when it comes to heat batteries, so somebody asked the questions about kind of fitting them in a cellar. So we wouldn't recommend fitting them in an outdoor environment. So it should be in a frost-free environment. We do suggest it's fitted in an indoor installation only. So obviously, the thing to consider would be frost if it's fitted outdoors, and your high heat losses as well. So you fit out, the customer says, I want it fitted there. It's outside, in an outside environment. All right, it's going to be in a shed or something. which is undercover. But you've just got to make sure the customer's aware that, okay, that you could get frost building up in there. Because obviously there's heat does come off the unit, although it is heavily insulated. You get some heat coming off there, so that is a form of condensation that could start appearing on the electrics that are in this control box here. But also you've got the heat loss factor as well. So what will end up happening is the customer will end up calling you, complaining of lack of capacity. You know, in the summertime, it's great. I get more than enough hot water. Come winter time, I've got nothing. I get half the amount that I need. And that's because it's found outside. The heat losses will just be much higher. So, like I say, if you can't get away with a weatherproofed outhouse, you just have to consider that outhouse is insulated. I know that there's some companies that sell this heat batteries and the heat pumps as a package where you can fit them all outside. And those outhouses, I call them outhouse, but it's just like an external compartment, but they're insulated heavily. So that's just something to consider. All right. So obviously that's a over exaggeration of what to do, but yeah, just don't do that. So that's actually a heat battery on its side. Try and keep it as upright as possible. So do not tilt more than 45 degrees during transportation or installation. So a couple of reasons for that. Because of the latent heat, so the batteries are discharged before they leave our factory. So they should be in their cold state, in a solid state before they leave. But because of the latent heat aspect, some molten PCM may appear after that. So if you tilt it more than 45 degrees, there is a risk that the PCM can come out of the breather cap. All right, so that's the reason for that there. And also, if you start to go over 45 degrees, you may get overwhelmed by the weight of the unit. The units can be quite heavy. So if you don't have your PP on, you're going to get a sore toe, basically. So yeah, try and keep it upright as possible. Yeah, obviously talking about PP, the plumbers here have roped the painters and decorators in to try and get the, I doubt the Nike have a steel toe cap in their inventory, but you can see what these guys are doing here. They're dragging a heat battery up the stairs. You could argue that staircase is less than 45 degrees, but what happens when they get up to this landing up here? Are they standing the unit upright and lifting it up that last step? They're dragging that thing all the way around and up. So that one side of the battery is going to be completely totaled. And you don't know what damage has occurred inside the unit as well, just bumping it up the stairs like that. All right, so yeah, and that's the thing. That's a Thermino 300 as well, which is our biggest unit. So it's going into a flat. So that's the thing. If you've got to kind of think to yourself, right, this has to go up there. How am I going to do that with a unit of that size? So yeah, don't drag up. So the point of that is just make sure you've got the correct equipment. You've got a sack barrel trolley here. You've got a heavier duty one there. So obviously look at the weight requirements or weight capacity that the trolleys can handle, and then compare that with what you're actually transporting as well. So these would be okay for like a ground floor installation, for example. You might be able to bump it up a step or run it up a ramp to get over a threshold of a doorway, the customer's house. But if you're going to be using it going upstairs, you really need some form of stair climbing equipment when you start going up to the 210s and the 300s. So, I mean, this is just one company. We've got this stuff on hire from a company called Zonzini, the body lifts, which can go up to a 210, and the Domino, so the stair climber. You see, it's got treads on it. It catches the staircase as long. Well, again, this is things you have to consider. If you've got a carpeted staircase, you wouldn't be able to use that because the treads will end up just churning up the carpet. So if you're thinking of getting a 300 up the stairs, how do you do it? I mean, I went to a job and the builders had a Thermino 300, so I just got asked to go just to sort of quality assure the job. And the staircase was too narrow to get this 300 up the stairs, so it was too narrow for this stair climber to get up. And there was 4 burly builders lifted a Thermino 300 up the stairs. So there you go. There's a will, there's a way, by using lifting straps and things like that. So they did it, and the staircase was still standing at the end of it. You can use other stair climbing companies if you want. Like Sano do a pretty decent stair climber. I think HSS, they do one as well. In fact, Speedy Hire, it's Speedy Hire that actually rent out the Sano. So there's other companies out there that do it. So just some considerations to make before you do your install. So this was all under that had leaked and just knackered the floor. So if you are going to fit anything on top of that, just don't put it right on top of it. Just reinforce the floor. So make sure that the wood's covering the joists. So you've got a nice stable support there. That's just 18mm ply that's on there, or the same thickness of the floorboard. So it'd be 18 to 22mm. It would be so. But that's the thing, you wouldn't have to specially reinforce the floor when fitting a heat battery. So the heat batteries, although they are heavy, they're actually lighter than their comparable cylinders. So we'll talk about that in the specification table. So yeah, that's the correct way to sort of deal with that. Don't use detachable hoses. So we're looking for rigid pipework to be connecting into the heat batteries. People might be tempted to use flexible hoses, or something similar to that, or plastic. We're looking for rigid copper pipe to go into it. Once you go, so what I would say is from your isolation valve, you should just convert that to copper to the heat battery circuit, as I call it. And when you're coming out of the TMV, you can downgrade to or convert to plastic or whatever if you want to be. You have to have rigid copper going into the battery, okay? So somebody got a bit trigger happy with a blowtorch there, but no hot works next to the battery. you can use solder, but I mean, we're kind of getting away from hot works and certainly in housing associations and towers and stuff after Grenfell. So, but yeah, that's not to say you could prefabricate your soldered fittings if you're a demon with the blowtorch, and then fit them after that. But yeah, just obviously be careful with stuff like this. So it's not suitable for a tank-fed water system. So we're converting from a tank-fed system to mains water, aren't we? So if a customer says, yeah, this is what I want, just say it's not possible. So because we're looking to move from that, and that's something else to consider as well. So some tanks, depending on the size of the house, that tank may give you like a great head of pressure, whereas their mains pressure might be absolutely rubbish coming in. So that's something else to consider when you talk about assessing the job. You know, that's part of your assessment, isn't it? Checking the water pressure coming out of the house. Is it meeting the 1.5 bar requirement, minimum requirement that we need? So yeah, so that's that one there, not for tank fed. So water, our heat exchanger must be pressurized with water before turning on the electrical supply. So you might get the scenario where the sparky will go in, he'll do his work, turn it on just to test it, which you want to do anyway, but he'll maybe get distracted, or they'll like leave it on by mistake, and then the plumber comes in a couple of days later and he's like, bloody hell, that's roasting hot. It can actually damage the heat exchanger and make it overheat as well. So don't get me wrong, you probably like turn it on for like a couple of minutes just to make sure your wiring and everything's correct and the unit is working. But just always make sure and turn it off. But ideally, just make sure that the water's in the heat exchanger before turning on the electrical supply. So that's the right way to do it. So, so yeah, I mean, don't stack the heat batteries on top of other, or put other heat appliances on top of the heat batteries. I mean, that's just, yeah, I don't know if anyone's ever done that, but I mean, to me, that's an eyesore. Why the customer would want that in their house anyway? I mean, the heat pump isn't even fixed on the top of the heat battery. There's no screws there. So yeah, that's not to say you couldn't, if you had like racking, if you had a big plant room or something and you had racking that was capable of holding the weight of the units, you could fit the heat batteries on something like a racking system. But yeah, I mean, we do have electrical components in the top there, which you might have to access over time, so just make sure they're not stacked. The product must be earthed properly, so the amount of times I see this, if I ever go to a job, it's, you know, I've lost count. So that's, we've got an earth clamp here, which we just, excuse me, asked to be fitted onto the, ideally the coal mains pipe, but all the pipes are connected to the heat exchanger. So sometimes if the coal mains is coming out one of the shorter, it's got a shorter length on it, depending on what exit it has or entry it has, then you might not have enough space for that earth clamp, so you can fit on another pipe if you want to. But what the earth clamp's doing is completing the earth circuit of the heat battery, so it has to be fitted. And it's just a regular earth clamp, 10 mil squared. So must have our own dedicated electrical supply as well. There's a couple of these, a couple of sites that I've been to. You've got the heat batteries just, I mean, tying into the ring main circuit of the sockets and things like that. It's, you know, you're just going to give yourself problems. So 60 amp breaker back at the fuse board. That's what we need. So, in fact, both of these are, you know, I've seen both of these scenarios as well. So I've seen heat batteries wired into a plug socket. I've seen heat batteries wired into a fused spur. So the minimum requirement for an double pole isolator is 16 amps. All right. So that's not right. But when you search 16 amp isolator, it comes up with a quite industrial looking rotary isolator. So you go up to the next size up, don't you? 20 amps. So that, we just want to make sure that this isolating switch is capable of withstanding the current that's going through it, because units will run at 12 and a half amps. So although, yeah, these might be rated at 13, but because you're touching the higher limits of what that switch can handle, any resistance built up in the contacts is just going to cause a burnout and make the switch go brittle and fail. So I've seen loads of them. So just make sure you've got the right size. So that's just a 20 amp double pole isolating switch. That's the right one to use. So I've got some more questions for you. So what I'll do, I'll leave this on the screen for a couple of minutes, and then we'll go through the questions.
We've got a few questions in the chat as well, Stephen.
All right.
So someone's asked, can additional insulation be added to the outside of the unit?
You can do. I mean, well, just wrap it round in glass wool. Are you meaning? I mean, it's nothing wrong with that. I mean, it's not going to affect the unit in any way. There's no ventilation requirements. It's not a question I've been asked before, actually. That's a good one. But yeah, if you're going to wrap it in insulation, then if you ever have to work in that unit for whatever reason, you've just got to take that insulation off. So we'd probably be saying no to that.
Someone else has asked, what is the weight of the smallest unit and the largest unit? I think when you were probably showing that picture of them going up the stairs.
Oh, okay, well, we'll cover that in the next couple of slides. So we've got this, that's all on the specification table, so we'll go over that.
Perfect. Someone's asking, can the units be fitted to boosted systems?
Yeah, well, booster pump, yeah. So if that booster pump is, going to achieve a pressure of 3.5 bar, for example, yeah. That's going to be
great. And then another one asking, are you able to install 2 heat batteries in parallel with one heat pump supplying both of them?
Yeah, you can do. The problem you're going to have with that is, will the heat pump be able to keep up with the demand? So with the 2 heat batteries, your timing cycle for the heat pump would probably have to stay on for longer, obviously, because you're heating 2 appliances. So, yeah, you can do it. You just might have that might just have a negative effect on the heating system. You know, so you might have to have it, the hot water, for example, come on at like 2 in the morning and be ready for the heating to come on at, say, 6 o'clock in the morning for the customer.
Okay, makes sense.
All right. Was that the last? Have we got any follow-up questions from the answers?
We've got lots of answers to the questions on the screen, which is good.
All right.
Someone was asking about the switch. So it must be a 20 amp pole switch. It cannot be a 13 amp fuse spur. Is that correct?
That's correct, yes.
Cool.
So, okay, so let's go through the questions. So it looks like we're almost there. So where should the heat batteries not be installed? Possibly have one heat battery and, have one heat battery connected to that interface, but cascade them in series, potentially. Or, or still use them in parallel, but you'd have to have one that's the master and one would have to be the secondary unit. So communication-wise to the heat pump, I'm not sure what the heat pump's capable of doing when it comes to those types of units, or those types of configurations, sorry. So that'd be a question you'd have to go back to your heat pump manufacturer with.
Okay, cool. And someone's asking, just to double check, can it come off a ring main, sorry?
No, it'd have to be a dedicated electrical circuit.
Right.
So if we get back to that picture there. So it'd have to be a dedicated MCB back at the fuse board, or RCBO, whichever you want to use.
Okay, great.
All right. All right, so hopefully a lot of your questions will be answered on this table. Certainly they can answer a lot of your customers' questions if you know how to sort of navigate it. So we'll start from the top. So from the 70 up to the 300, we've got our heat storage capacity of each unit in kilowatt hours. So the 70 will store 3.5 kilowatt hours of energy within it, up to our 300, which will store up to 14 kilowatt hours of energy. All right. So then you go to your water content of the heat exchanger. That's the water content of the heat exchanger at any one time. So obviously less than 15 litres, don't have to comply with Legionella. Happy days. Our comparable cylinders relating to our heat batteries. Yep, so good there. So the V40, I've always quite liked this row here. So if you set we had a blending valve on our batteries, okay, so that's part of our mechanical components fitted to the plumbing. But if you set that blending valve to 40 degrees on the outlet temperature, this is what you can achieve from the heat battery. So 70 litres is essentially up at 105 litres. From our 300, you can actually get 436 litres. So when I was talking about the Guatemala project that we had, the interesting thing with that was they had fitted a bunch of 150s, and you see there the V40 is at 100, just under 200 litres, 199 litres. But their inlet mains water temperature is 20 degrees, so they doubled their V40 up to 400 litres. From a unit of that size, that's what they were getting out of it. So it was pretty incredible stuff to get fed back to us. So, but it just shows you what the unit's capable of. So these V40s, that's based on a 10 degree inlet temperature. All right. So obviously in the summer, everything's going to be great. The world of plenty. But again, it's just something to bear in mind when speaking to your customers. In the winter time, the mains water temperature will be a bit colder, won't it? So that's going to have a higher heat exchange going on inside the unit because you've got colder water entering the unit. All right, so that's just stuff to bear in mind. Your heat losses for the unit, so yeah, 0.48 for your 70, all the way up to your 300, so we're less than a kilowatt hour of heat loss over a 24-hour period. All right, so somebody may ask you, how long is my heat battery going to last if I have it fully charged, I don't use it? So what you would do is you would take your storage capacity, so let's work on the 70, your storage capacity, 3.5, and you would divide that by your heat loss, 0.48, and that gives you your length of time in days before you're at 0%. So if everybody wants to do the calculation with me just now. Let's see. So I should know this off the top of my head, but I don't. So yeah, if anybody wants to put their calculation at the chat. Or do it for any of the units if you want to. So yeah, you would just divide your storage capacity by your heat loss. Have we got any answers, Sarah?
Someone's saying 7 days?
Yeah, that's it. That's exactly it. So again, another thing to bear in mind is these, obviously, it depends on your ambient conditions inside the house as well. So if if you're a hot person, or, you know, my wife certainly isn't, so my house is always at a nice comfortable 30 degrees, then yeah, my heat losses will be great for this. But if you're, you don't have the heating on so much, you're going to be less than 20 degrees. So these calculations are based on a 20 degree ambient temperature as well. So when you, again, going back to your external outhouse installation, what's your ambient temperature going to be there? That's going to be much higher, isn't it? So the reason I sort of emphasising that, we do get some of these jobs, customers call us saying that they're not getting enough hot water, and that's the reason why, because the heat losses are higher, or their energy, or they're on the opposite side of the coin, their energy usage is higher because they're depleting. Their natural heat loss rate is much higher, so then they're using more energy to charge it up, especially when they're not using it. You've got your minimum supply pressure, 1.5 bar. So maximum, I think we are changing our guidance on this. So we do say maximum pressure of 10 bar. So that's to accommodate any fluctuations. But what we also say is, thankfully we're starting to change it, is if you feel, or you do your pressure test, your water pressure test, or if you feel that you're at risk of exceeding 5 bar coming into the house, you should have a pressure reducing valve on the pipework going into the battery. So we don't want really any more than 5 bar going through this. All right. What that 10 bar is if you had a failure of your pressure reducing valve and your expansion relief for whatever reason didn't work, then yeah, it will take that spike, but we don't want that constant expansion, going into expansion contraction, high pressure, low pressure. Because I've been in homes and 2:30 in the afternoon and the pressure's at 4.5 bar. What's that going to be at 2:30 in the morning? Massive chance that's going to be higher than 5 bar. So to me, that's a system that's at risk of being more than 5 bar. So the advice was to get a pressure reducing valve put in the system. Our units, I've got a 2.8 kilowatt element in the base here. So all units are the same, 2.8 kilowatts. So which will be running about 12.5 amps. But when you take your charging times, it's just another question customers will ask you. You take the storage capacity, so up here, and you divide that by your 2.8 kilowatts, and that'll give you your length of time in hours before you're at full capacity. So if somebody want to, take a 210, how long would a 210 ePlus take to charge up from the element?
Someone's asked in the chat, this might be related, would you know the recovery time of a 70 ePlus with a heat input of 65 degrees?
So this is a heat pump question. So another heat pump question. Okay, so we don't have a 70. We don't manufacture a 70 for heat pumps because we don't get the uptake on it. I mean, if requested, if it's going to be a one-off or something, we could make one, but it'd be a special order. unit. So
Sorry, they're saying it's not a heat pump question, so it was the 70 ePlus with a heat input of 65 degrees.
So that a heat input is 65 degrees, so it's still, you're still relating to indirect. So
From a boiler, sorry.
yeah, so it's not, that's a module 2 question. That's an indirect.
That would still be an X
That's
plus.
an X plus question.
Okay, so tune in next week for the answer.
So, but it's all on. Again, we don't do a 70X plus for boilers. So it's all to do with the kilowatts. So if you've got the way I look at it is, if you've got a 10 kilowatt appliance, all right, and you've got a 210, that's going to take about an hour to fully charge, because you're inputting 10 kilowatts into it. It's going to be using 10 kilowatt hours. And if you've got a 30 kilowatt boiler, it's going to be, well, yeah, a third of that time. So hopefully that answers your question. But yeah, I don't want to muddy the waters too much, because we just want to concentrate on the indirect models today. All right, this is just our grid electric and PVs.
Great. You've got a thumbs up
Yeah.
in the chat, so all good. Someone's asked if we can go over the calculations quickly again, or are they written down somewhere? Is that in the manual or anything, in terms of how to work this out?
It's not, I'm afraid. So yeah, it's so your your heat loss calculation would be your storage, your storage capacity. If you want to make a note of these, we'll send these slides out to you guys, but if you want to make a quick note of these storage capacities, this is a really good one for when you're speaking to your customers about as well. But yeah, take your heat storage capacity, you divide it by the heat loss, and that gives you your length of time in days before the battery is fully discharged. And your charge times is your heat storage capacity, again, divided by your element size, which is 2.8 kilowatts. I need to take that comma away, and I need to take those 2 zeros away, but essentially it's a 2.8 kilowatt element.
Makes sense.
Yeah. Somebody mentioned the weights of the units. So yeah, we're not getting away from the fact that units are heavy. So yeah, our 70 is 75 degrees, our 150 is 136, our 210 is 172, and then our 300 is 220. So they are quite heavy, but lighter than their cylinder comparison. So when you think about a 300 litre cylinder, you've got 300 kilograms in there already. Never mind the already weight of the cylinder in itself. So that's why you don't have to make any special reinforcements to the floor if you're replacing a cylinder for a heat battery. All right, might be different if you've got if you're in an old cottage or something, and then the customer's got a 70 litre cylinder and you're looking at putting a 300, you maybe have to look at it in that sense. But yeah, if you're doing like for like, you don't have to worry about it. So yeah.
We've got a couple of other questions. So someone's asked, does the outlet water temperature decrease as the unit depletes?
Yes, it does, yeah.
Okay.
So,
sorry, on you go.
No, I was just going to say, so yeah, this is why you need your thermostatic mixing valve, because your initial, once you're up to temperature, your initial outlet temperature is going to be up to 75 degrees coming out. And then you'll see if you never had a TMB there, yeah, your temperature graph would be, it would just come up and just sort of nosedive like that. But yeah, it does decrease, but your TMBs obviously will give you a more moderate constant. Say at 40 degrees, it's going to have a much more shallower temperature loss, like that.
Okay, and does the phase change material fully discharge over time?
It will do, yes. So your standing heat loss rate. So again, if you use your calculation for the 70, again 3.5 by your heat loss calculation, it will take 7 days to fully lose its heat, fully discharge itself. Yeah. So, but essentially, you could go away. You could fully charge a 70 and go away for the weekend. Turn it off at the timer, and come back and still have hot water there. It wouldn't be at full capacity, but you've lost. probably half your capacity, but you've still got hot water to come back to for washing your hands and doing the dishes that you never had time to do before you left.
Great. And someone's also asked about naming. So have Sunamp revised the name of the units recently? The direct ones we installed recently was the EPV, so that would now be the ePlus under the new.
Yes. So the EPVs, so Thermino E's, EPVs, that's what we're calling fourth generation stuff. What's the difference between an EPV and an ePlus? We've added a PCB in the box. That is it. The unit's the same. It's the same heat exchanger. It's the same PCM. It's the same fascia. It's the same grommets that are there. It's just what we've done is we've added a PCB. So we'll discuss that as we go. But what the reason for it is so we can make the units more multifunctional. Because with your EPV unit, that was designed. The software on the PCB for that appliance was designed to work with PV. Whereas with a Thermino E, it was designed to work with grid only. So if the customer had a Thermino E and over time they wanted to upgrade to get solar panels or what have you, in theory that unit wasn't as compatible with that system as your EPV was. So hopefully by doing this design change, it's making the unit more multifunctional for future proofing for the customer. But if your customer's got an EPV fitted, they've future proofed it anyway with the solar panels. So I've got a thumbs up there. I can't see.
No, I think that's all. And just someone double checking the calculations that it's storage capacity divided by heat loss is how long it takes for the battery to run dead, and storage capacity divided by element size is the charge time.
Yes.
Perfect.
All right. And last here we've got our obviously different sizes. You can see the footprint stays the same, the depth and the width. It's just the height that changes. So 440 mil high from our 70, 640 for our 150, 870 for the 210, just over a meter for our 300. So quite powerful units for their sizes. I'm just kind of throwing this slide in just to show you the difference, mainly the heat losses in the V40. So this is another well-known cylinder manufacturer. But if you look at the heat losses, so even if you look at the 70, the heat losses there, 0.91 versus our 0.48. So that's a massive saving for the customer when it comes to energy use. If you go all the way up, your one comparable cylinder heat battery be a 150, so you're over a kilowatt heat loss for that unit. Oh, wrong button. We're just over half a kilowatt of heat loss for that unit. And if you go all the way up to the 300 litre cylinder, you're 1.69 kilowatt hours heat loss over a 24-hour period compared to our 0.84. So it's less than a kilowatt. So the cylinder's almost double your heat loss. Your V40s, mixed water at 40 degrees. Okay, the 70s, up to your 150s, there's not too much of a difference there. Yeah, we're still kind of exceeding it. 105 litres for the 70, 199 for the 150. So not much difference here, but we go up to the 300 litre, 241 litres you're going to get out of a 300 litre cylinder at 40 degrees compared to our 436. So it's massive. 210, where are we? 241 versus 300. So we're exceeding it in every way, although slightly, and some more so, but still. It's just to show you the comparison from cylinders to our heat batteries. So the inside story of the heat batteries. So we do have single and dual circuit models. So if you get a Thermino ePlus, the 70, 150, 210, it'll be a single ported model. So that'll be one pipe in, one pipe out. If you get a 300 ePlus, it'll be a dual ported model. right? So they'll always have 4 pipe connections. The X pluses will always be dual circuited. So flow and return connections, and then cold water in, hot water out connections. We've got these Tektite elbows here that you can fully rotate, so you can have left, right, entry, exit, and rear. Or you can have a left entry and a right exit if you wanted to. So trying to be flexible as we can. You've got your element, which is fixed, embedded in the bottom here, your 10-year warranty, and that's your heat exchanger. So essentially, what is a heat exchanger? We've got a coil of pipe with aluminium convector fins. So just think of it like almost like a car radiator that's sitting in this plastic cell here, and it's enveloped by this PCM. So once the PCM's up to temperature, you run water through there, and all it's doing is catching a heat. And that's essentially what's creating this phase change chain reaction. All right, so it's the movement of the cold water which is causing the chain reaction. As soon as you stop the water, the chain reaction stops. So I get asked a lot, so is it like a hand warmer? When you click the button, it just depletes everything. No, the components are slightly different in our PCM. The chain reaction starts and stops with the movement of water. All right. But yeah, and that, like I say, you've got your electrics up here, electrical box, and your temperature sensor. That's your breather cap. So again, if you do tilt more than 45 degrees, that's where any molten PCM may come out. So it's just let you know where all that is. So when we talk about the operation of it, so we've got a heating element at the bottom. So obviously we're charging from the bottom up. Cold water comes in, and we start discharging from the top down. All right. So the way I like to sort of think of this is the water, it's preheating as it's going through the battery. All right. And it's obviously depleting the storage. So this is why it's quite important to make sure you've got, if you're using a timer, make sure the timing cycles are set correctly for that size of unit. So, I mean, I get a lot of jobs and the customers have got them set to 2 hours, and then they call up saying, I'm not getting enough hot water. Yeah, they're maybe getting a shower, but they're maybe not getting 2 or 3 showers out of that. It's because they've not got the timing cycle on long enough. Or even worse, you get customers that don't have a timer and they've just got a double pole isolating switch. And what they do is they think it's like an old school immersion switch, and they put the power on for an hour and then they turn it off again. Never going to work. So, because if you think about that, if you're only at half capacity, your preheat's only going to start here, isn't it? You'll still get hot water, but you might not get the full capacity for the customer's requirements. So that's why it's important just to make sure that the customers, it's all about managing the customer's expectation, isn't it? So yeah. Have we got any follow-on questions there, Sarah, for what we've covered before we?
Yeah, we've got a couple of questions in the chat. One asking, is there an option of an outdoor unit, which I know we've kind of covered already. Great. And then final question is, would it
storing? That's what the phase and the size, it ranged from 3. So the element comes on, you're doing your paperwork, you're tidying.
DC be used, or does the PV supply need to be AC 230 volts?
Yeah, really good question. So our solar diverters have got to be rated at 16 amps, but also have an AC modulating output. So yeah, we sort of learned from that. It's based on the answer. So yeah, the DC, from what I believe, the arcing for DC is much more powerful, and it just destroys electrical components that are AC rated. So you'll get a lot of burnouts across the board. I mean, one job that we did have, it was a solar iBoost Plus, and I think the circuit breaker and the fuse board fused in the closed position and wasn't able to trip. That's how dangerous it got. And obviously, installer wasn't interested. We had to take ownership of that for the customer's sake. Yeah, we had to rectify everything, change the solar iBoost Plus was knackered as well. So I had to take that out, put in an eddy, AC modulating output, and change the plug socket that was also plugged into as well, and other associated wiring. So yeah, AC modulating output only.
Thanks, Stephen.
Cool. So work mechanical connections. So if anyone's ever worked with, well, somebody mentioned an EPV there earlier. So the previous models of heat battery, the pipework changed depending on what the application was. So due to popular demand, we've now universalized the pipework connections. So the ePlus, you could have it working off grid electric or PV, and you're going to have one pipe in, which is your cold going into A, and then your hot pipe coming out of D at all times. So that's going to be your pipe connections with the ePlus always. So essentially, if you'd fit it like this for grid electric, customer converts to PV in a couple of years, you don't have to change the pipework. It's the software that recognises what's going on. All right, so there's your Tektite elbows. You can have them, you can rotate those left, going out the back or going out the right hand side. You've got your earth clamp there. Obviously, this one's not being fitted yet. Clamp on there. If that's your co-mains is coming out here, out that side, there might not be enough length of the pipe, so you can fit it in the longer leg of pipe if you want to. But it's almost like a good practice thing for us. But yeah, it's still going to be earth in that heat exchanger, which is what we're wanting. No hot works within 1 meter. The heat battery as well. We also say that you should have at least 1 meter of insulation fitted to the pipework with for at least a meter, because obviously heat's transferable to copper. If you've got any sort of vertical rises on your pipework as well, you want to try and insulate that. So yeah, with that in mind, yeah, if you do have a vertical rise, what we're sort of finding out is, yeah, you're getting this thermal siphoning thing happening. So your heat losses may be increased due to a vertical rise coming straight off the battery. So what we'd be recommending, it's not a must, but what we'd be recommending is having a small U-bend to stop that vertical rise. So that down rise is going to stop any heat escaping, because heat wants to go up, doesn't it? And then obviously you can go up if you want to. You've got your recommended maximum flow rates. So for the 70, we're recommended 6 litres per minute. 150 is 15, the 210 is 20. I mean, if you're fitting a Thermino 70 and you've got 8 litres per minute, it's still going to work. Again, we've got the note here at the bottom. It can work with higher flow rates. It just means that your capacity might be slightly less, because the water's running faster, so there's more heat exchange going on for that size of unit. All right, so it's just something to bear in mind. I mean, I've been speaking to customers, and when I've been in their house, and their flow rate for a 70 is running at 10 litres per minute. So you obviously have the conversation with them, and they're not experiencing any problems. They're happy with it. So, let sleeping dogs lie. But it's just something to bear in mind. I mean, I had another job, but it was a 150. It was fitted down in Liverpool. The installer went AWOL, so couldn't get in touch with the installer. So anyway, I had to go down. The customer was only getting about 2 inches of hot water coming out their bath. So anyway, drove down to Liverpool, found that the flow rate was up at about 28 litres per minute. So almost twice what it was meant to be. So we stuck a valve in the outlet of the TMV just to restrict that down to 15. We've never heard back from the customer. So this is all just part of the sort of commissioning that you should be doing on site. So just sort of bear it in mind. Your Thermino 300, So you see the difference. You've got a single port model for the 70, 150, 210 up to the dual ported model, 4 pipes. Maximum flow rate 25 litres per minute. If you're getting that in a customer's house, you want to watch. So it's going to be like having a shower. If you're on holiday in Spain, it's going to be that powerful. But what we're looking to do is you can convert, we supply these copper branch kits here. All right. So you've got 2 pairs. You've got a short narrow and a long narrow, and you've got a short wide and a long wide. So the narrow pair are for our side exit, and the wider pairs for our rear exit. All right. So just if you're fitting a 300 ePlus and these branching kits haven't been supplied, speak to your stockist, because they'll be supplied to your stockist. So because in a warehouse things are moving around, they may have misplaced them and forgot to add them to the battery before sending it out to you. Just double check that. I mean, you can get away with fitting, having your pipework coming out and using a street end elbow straight into a T-piece. That would still work. But again, you've got no hot works within the battery. So again, your shoulder has got to be pretty spot on to deal with that. But that's how you would get around it, is using your street end elbows into a T-piece. But it's easier just having the branches because you just plug them in, plug and play. All right, so that's your rear exit. So you've got your short wide, your long wide. And then you've got your side exit. So you've got your short narrow and long narrow. And then you've got a mixture of the two. So long narrow and long wide. Short wide, sorry. All right. So it just shows you the flexibility units. So yeah, so I was just answering these ones for you. So again, the only reason I'm putting the ones in there because with the older units we used to. So for your EPV that you fitted, whoever asked that question, is your cold inlet would have went into port D, wouldn't it? And then your hot would have been coming out of port A. Whereas now it's universalized. Cold's A all the time and hot's D all the time. So what's the difference between a Thermino 300 ePlus and the other sized units? Can anybody answer that one? Have we got anything in the chat there, Sarah?
Someone said flow rates, someone said 4 pipe, and someone else has said dual heat exchanger.
Yeah. Well, actually, flow rate, exactly. That's a good one as well. But the main difference is the Thermino 300 will always be dual ported, or it's like a twin pass heat exchanger, essentially. What will be supplied with a Thermino 300 ePlus? Or what should always be supplied with a Thermino 300 ePlus?
Pipework?
Yeah. Copper T branches. Excellent. Have we got any following questions from that? I mean, you're installing the pipework, aren't you? You're plugging and playing, really. It's nothing to it. The main takeaway from that is really the flow rates, is what I would say.
Yeah, we have nothing else in the chat yet.
All right, cool. So we'll move on. So applications. So you've got your house here on the left, a traditional UK household, open vented cylinder, your cold water storage tank in the attic and all that. So you've got the risk of poor head of pressure and everything coming out your cylinder. Bit messy. And obviously, yeah, I mean, people still have that in their house to this day. They love it because they can heat their towels and they leave the dog's towel on top of the cylinder to dry it off and stuff after a rainy day. But what people forget is it's the heat losses are so much higher. It's pretty much almost a bare copper heat exchanger. The one on the right's a little bit better, but again, you've still got higher heat losses from that. So, whereas you've got the house on the right hand side, you've got a much more direct hot water plumbing system, hot water cold plumbing system. I mean, I had a job, and well, I never had a job. An installer had a job, and he phoned up saying he's got a customer experienced capacity issues with a 70E. And what he'd done is, he'd fitted the battery downstairs in the kitchen, but he still had all his original pipework up here. All right, and he never fitted a TNV. He relied on the TNVs on his tappings at his bath and his sinks. So what he had was his hot water was coming out, but it was still going all the way up into the attic and connecting up here, and then running all the way back down and then into here. So if you think about that pipework, you've got that raw thermal energy leaving the battery and going up into the attic and all the way back down again. So by the time it gets to the tap, you'll hopefully it's within 30 seconds, but you've still got that line, all that heat lying in that pipework, haven't you? So we recommend having the TNV fitted here at the battery itself, so it's blended at the source, and then it goes. But also I mean, to be fair to the installer, once I explained that to him, he rectified it and made it a more direct plumbing system. And he says, brilliant, it's working, the customer's happy, and that's what we're looking for. So obviously you want that pipework insulated as well. I know certain housing associations, we talk about the V40, but housing associations are saying, like, between 50 and 55 if you're doing work for them. That's what you set the TNV to, and then they've got their blending valves at the tap to bring that down further. But yeah, you would just be looking at that pipework insulated there. So somebody mentioned a back expansion relief valve, or a 6-bar PRV as we all know it. So yeah, if you can get away with a flow group combination valve, brilliant. If you're just you can just tie into the D2 and obviously drain away your expansion from there. But if you've got like an internal cupboard in the house, and say it's a flat or something like that, what you could do is you could put your pressure reducing valve at point of entry to the property, and then obviously your battery would be here in the cupboard, but you could tee off your cold mains under the kitchen sink, and then tie that termination point into the waste of the sink. All right, so that's your way around. So you've got the two options. You've got your combination valve, your flow group combination valve, or you've got your two separate. You've got your pressure reducing valve, and then your expansion relief valve. All right. Has anyone got any questions on this slide?
We've got a couple of questions, yeah. One asking, can you use plastic piping?
So you can, but what I would be saying is, so what I call the heat battery circuit. So think of this square as your heat battery plumbing components. That would have to be your rigid copper. So say you've got your isolation valve here, you could have plastic running to here, but what we'd be doing is changing that from the isolation valve into copper, and then obviously copper into your TNV, hot water coming out of the battery into copper, and then from the TNV you could change to plastic. But
okay, yeah.
But that's
someone else has said if it applies the same as boilers, you can 1 metre away from copper pipes. So I think that's what you're saying.
Yeah, it's the same sort of standard we're looking for. Yeah.
Cool. Someone else has asked, have you ever done an install with a HW ring supply?
An HW ring supply, hot water ring supply, is that?
I don't know.
sorry, can you elaborate a little bit on an HW ring supply, please? Like a secondary return, do you mean?
Someone else has said domestic hot water return, so that might be what that.
A secondary return, yeah. So you can do it. So yeah, your secondary return, yeah, of course you can. How you'd run it, hot water coming out, going around, but where you would tie that into would be your so that this would be your, obviously you'd have your isolation valve and your check valve to stop any backfeed, but you would tie that return pipe into this inlet point here. So that's where you would tie it into. All right.
Okay, great. And someone else has asked, if you fit the PRV on the property with a combi valve, as it has a check valve in it, wouldn't it need to be after the valve?
the combination valve, the expansion relief would be after the check valve anyway. So that your pressure reducing valve is essentially your non-return valve in some cases, but the expansion relief would be after that within a combination valve.
Okay, great. I think that's everything in the chat so far.
All right, yeah, just give me a shout if anything else comes up. But yeah, so your ePlus. So when we talk about PV, your PV system can produce up to 70% of your hot water demand. All right, yeah, passive house option as well for that, and also we're compatible as a preheat to a combi boiler. So this is I've seen a few of these installations. So basically, your PV is charging up the heat battery, comes out hot into the boiler, no requirement for the burner to come on because it's hot water, and then the outlet that is going to be hot. So the one thing you've got to remember is what's the boiler manufacturer's what's its maximum inlet temperature allowance. So that can range from manufacturer to manufacturer. I think Alpha, I think it's 65 or plus that. The new Woosters are up to 65 degrees. But Viceras, for example, I think it was a Vicera Unica that this installer was fitting with this configuration. Their maximum inlet temperature is 15 degrees. So what they done this installation, but the boiler kept locking out saying inlet, the code was like inlet temperature fault or something like that. So you couldn't fit a Vicera Unica in Guatemala, obviously. But that's what they ended up having to do is fit a blending valve to blend that down to 15 degrees and then go into the boiler. So it was pretty pointless doing it that way. It's because the boiler would still be coming up. But when the temperature starts to go down or there's not as much PV being used, yeah, the boiler's going to come on, but not at its full gas rate. You know, it's going to be, instead of like banging out 30 kilowatts, it's going to be 10 or 15 kilowatts to start with. And then that's how it's going to work from there. So you're still making an energy saving with that. But if you do get a boiler doesn't allow a hot water preheat, you can use a 5-port solar blending valve. All right, so that's your solution to that promise. So if your combi manufacturer doesn't allow a hot water pre-feed, a 5-port solar blending valve can be used. So the solar blending valve is an external component which can prioritize the heat battery's store. Then once depleted, it switches over to the combi water circuit. So it's a little bit like that in a nutshell. So once the hot water goes in, you're mixed. Once that's depleted, it then goes in there. Once that's depleted, it just prioritizes the boiler from there. All right. I mean, they are quite expensive from what I've noticed. Calefe, I think the last time I checked, it was like 280 quid or something like that. So if you get a cheaper one, give us a shout. It'd be good to kind of add that to the training slides. So we've got mechanical considerations to consider. So you've got high pressure. So we're changing from a tank fed system, you're changing from a low pressure system to a high pressure system, aren't you? So again, we have to make the customer aware that they may have some dripping taps. Everyone's going to be mains pressurized after that. Ball cock seals might start passing. So if you're in a hard water area, you've got risk of lime scale. So you'd have to have some sort of water conditioner or descaler fitted to the inlet of the battery just to protect it. We have had some jobs where there's no descaler and the customer's saying that the flow rate has went down to a trickle, and that's because of the lime scale build up in our heat exchanger. It's just reduced it like a blocked artery. and that's down to the installation defects really. And we talked about existing pipe runs and diameter and run lengths and stuff. So, but when it comes to components, so water isolation valve, best practice, fit an isolation valve to the unit. I don't know why you wouldn't. Pressure reducing valve, if the pressure is exceeds or is at risk, or you feel it's at risk of exceeding 5 bar, stick on a pressure reducing valve. Expansion relief valve, 6 bar expansion relief we're saying is always required now. Expansion vessels always required. TMV always required as well. So TMV is an anti-scald device, but also you can increase your capacity based on the V40, as we were talking about earlier. So, so your expansion vessel, what do you think you might have to do, or what do you think the customer might have to get done to that expansion vessel once a year or every couple of years? Can anybody tell me?
Someone's saying maintenance.
What kind of maintenance?
Repressurize, check the pressure, recharge.
Exactly. So, and what should that pre-air charge in the vessel? What do you think that should be charged to? What pressure?
The same as the PRV?
The same as the incoming mains pressure supply. So if you've got your pressure reducing valve set to 3.5, that's what your air charge should be. I mean, these are pre-charged to 3.5 bar anyway, or they should be, and that's another point to consider as well. How long's that vessel been sitting on the shelf for at the stockist? So always check your vessel's got the correct air charge in it. All right. So what? So now you've got your expansion relief always required, which is fine to this combination valve, which is fine to use as well. All right. So check valve and expansion relief downstream of that out there. What do you think might happen out this expansion relief valve if the air charge went flat or to zero on that vessel? Can anybody tell me?
Someone said lift.
Yeah, it would discharge, wouldn't it? So it would start to discharge. So that's the need for the relief valve, because we're getting a lot of jobs now where this advice hasn't been handed over to the customer, and this isn't being maintained. So if you've got a foot pump or just a battery operated tire charger inflator, then that's what you do. Boom, job done. But yeah, I mean, hard water, yeah, if you're exceeding 150 parts per million, you can use it like any water conditioner, descaler, or a water softener. Just make sure it's there if it's a hard water area. Right, what are the disadvantages of a traditional cylinder? I'll just kind of. Does anybody want to sort of answer that one? Come up against that, you can certainly just give us a call. We can sort of. But this is now a must, so that's an important one to consider now. All right, 6 bar expansion relief is a must. So always check the manual.
We've got some other questions just from before, Stephen.
Yeah.
Let me just scroll back. So a couple about the TMVs and the building regs. So someone had asked, you mentioned TMVs, is this a requirement on all hot water outlets? And someone said that the building regs require a max of 48 degrees on bath hot water tap. And then someone else was asking, is that for existing buildings and not new builds?
So if you're going to be doing any sort of plumbing work, you're going to have to fit a TMV to the systems, I believe. I'm not sure about the existing though. That's a good point. So again, I'll have to check the regs on that one. But yeah, your TMV from our unit yeah, I mean, put it this way: if you're going to have more than 48 degrees coming out the TMV, then you need to go and see a dermatologist, because your skin's going to be asbestos-like material, isn't it? So like if you set to 45 degrees, all right, give or take a degree or two heat loss in the pipework. If you've got 43 degrees sitting in there, it's like to me that's more than ample. I know everybody's different, but yeah, you just have to check your water regs with that one. I know housing associations, new builds, things like that. I'm not sure in existing properties if you're fitting to existing. I don't think you have to fit.
Someone else is saying if you change a bath tap, a TMV should be fitted, or you should tell the customer that should be fitted.
Yeah, exactly. So as long as you've given the advice, it should be You're covering yourself, aren't you?
Yeah. Someone else has asked, are you able to have direct immersion and PV added when generating?
So use from grid and PV at the same time?
Yeah, I think that's what they're asking. Or use from grid when the PV is still generating.
No, certainly that's not how the eddy works. So if you're generating from PV, don't think it makes up the difference with the grid. I think it will prioritize your PV and input that into your battery. So whereas your grid electrics, it's dictated from your time boosts. So like your eddy, it's not so. Yeah, so we've got a 2.8 kilowatt element. Say that eddy's only inputting 1.8 kilowatts into the heat battery. It's not going to make up the other kilowatt difference from the grid. It's going to. If it's diverting 1.8, that's all it's going to divert from PV, if that's all that's available.
Okay. Another question, this was when you were talking about the boiler preheat. Someone said unit flow rate and combi flow rate need to be within range of each other.
Mm-hmm. Yeah. So if
that was a comment rather than a question.
Yeah, exactly. So it's all part of commissioning. So if you've got a 210, a Thermino 210, and that's acting as a preheat to the combi, our unit will work up to 20 litres per minute, but you've got to work within the guidelines of the boiler that it's feeding. Exactly. So if that boiler's limitations is 14 litres per minute or 12, that's what you adjust the flow rate to.
Okay, cool.
But then the boiler should have a flow regulator on it anyway to limit the flow rate.
Okay, makes sense. I think that's all the questions from the chat, but there's been quite a lot of messages, so I'm sorry if I've missed any.
Don't worry, we'll pick up on it as we go. So this is this is when we start getting serious on our electrical connections. Hopefully, it's pretty straightforward. So your Thermino ePlus without wiring an external controller. So you're going to have your 3-core flex, live, neutral, and earth, factory fixed. Going back to your 20 amp double pole isolator, and that is it. There's a charge link that will go into 1 and 2, and that'll make the heat battery work as a hot water constant. All right. If you're fitting in a timer, it has to be a volt-free contact timer. All right, and you wire the volt-free contacts into 1 and 2. So you remove the charge link, run your 2-core from there to your volt-free contact timer, and then it comes on and goes off as and when there's a demand from here. So even if there's a demand from the heat battery, but the timer's off, the element's not going to come on. So that's almost like your master control. But it must be volt-free. All right. The ePlus with the PV key, you've got it's a little bit of a different configuration. So if you notice there's no key. We're not inserting a key in this little baseboard. So somebody mentioned about the EPV previously. I keep referring back to that one, but the EPV or the previous models only had one PCB. The only difference between those models and our current range that we have now is we've added this little baseboard. All right. And it's this baseboard that gives it that multifunctionality. So as an ePlus working from grid, you don't insert any key, you just wire it with a timer, without a timer, happy days. When it's with PV, you insert a little, it's almost like a little EEPROM key. You put it in here, and that then tells the heat battery it's working with PV. And all it's doing is it's changing the set point range with its sort of call for heat, and that's pretty much it. But you do have to do some rewiring of it though. So you've got your 2.5 mil 3-core flex going L2 into an earth. That would run to your output terminals of your solar diverter. You then have to run a separate 3-core flex from your L1 and N1 either to the load side of your double pole isolating switch or to the incoming supply of your solar diverter. All right, and then you remove the links. See, the links are missing there. So if we go back, see you got link 1, link 2. So all we're doing is we're bridging that permanent live over to the start of this contactor here, this relay. Whereas we remove the links, so we separate the lives and we separate the neutrals. And that can...
Someone's just asking, what does it change the set point to?
So for the grid only model, there's a depletion of, when you get a depletion of 20% capacity, that generates the demand. With the PV key, there's a higher set point of between 3 and 5%. So you use a minimal amount of water, and what that does, it doesn't bring the element on. But what it does is the unit makes itself available for PV. All right. So when you're looking at the unit, we'll cover this a bit more in the sequence of operation. But the element, so you use a minimal. You run the tap, fill a basin or something. You deplete your 5% charge. The element LED will become activated. All right. So the customer will look, oh look, that heat battery's on. It's not. The circuitry is activated. We're relying on that switch live to provide power down L2 to then put power into the element. All right, so hopefully we'll cover that in the sequence operation. The Optimino key, that's what it looks like. You just insert that into the little J2 terminal there, and that's the rest is history. And that's a range of available keys at the moment. We're still looking to expand our heat pump ranges, but you know, the VF01, that's the standard, or the 01 keys are standard, no PV required. The 02 keys, they're the PV keys. All right, ePlus with PV. That needs to be changed. That's not correct. But yeah, that's what to remember. So if you're just working with a standard boiler, whatever, S-plan system, no PV, it'd be a VF01 key. But if there's going to be PV there, it's a VF02. If you're just using a grid, if you're using an ePlus and you're upgrading to PV, it's a PV02 key. So that's just all on our website. So we do talk a little bit about eddies when we're here, but it's a bit of a busy slide, but what it's showing is you can fit 2 heat batteries to the outputs of the eddies. All right. I mean, how that works, you've got your primary unit and you've got your secondary unit here. So what the eddy does is it heats up your primary unit to 100% capacity, and then it starts to heat up your secondary unit for 15 minutes, and then it'll go back and check the primary. You can change that setting from 50 minutes to longer, I believe. I can't remember the segments, but yeah, but it basically does that back and forth until both heat batteries are satisfied. Plumbing wise, you'd have to fit them in series, not parallel. So your primary unit would be your outlet battery. Your secondary unit would be your inlet battery when it comes to the plumbing. So your coal mains would enter your secondary battery first, and then your hot outlet would be your primary battery, if that makes sense. All right, so it just shows you what can be done. So, and that's pretty much how you wire it up. So you've got your permanent supply coming in around there, into the incoming supply, the eddy, and then piggybacking off of that into your L1 and N1 and earth. So you just follow that back there. Your modulating live, your switch live, is fed from your output terminals here. If you just follow that, that's where you run them to their L2 and N2, and then obviously your earth. You'd have to leave your charge link in. All right, don't remove that because that's, if you remember, that's our element control circuit. So if you remove that link in this configuration, the element wouldn't come on. So with PV, the link's got to be in place. And also insert your key.
Someone's just asking, is there a maximum inlet temperature if in series?
A maximum inlet temperature? No. Not at all. So if you're, if you think about it, if your secondary battery is up to temperature, and the output of that is up to 70 degrees, boom, that's going into your primary battery. That's going to benefit this battery because there's going to be no heat exchange going on, isn't there? So even better. The only thing you'd have to consider with plumbing them in series, though, is the pressure loss across the heat exchangers. The reason with a PV configuration, if you have them plumbed in parallel, your primary battery is going to reach temperature first, and then your secondary battery. But if your secondary battery is not up to temperature, then that may give you a cold influx of water and start affecting the outlet temperatures. So that's the reason why. In a grid electric sense, yeah, you can fit these in parallel quite happily. As long as the timings are the same, or if there's no timer, even better, they'll just be charging constantly up to temperature. So you shouldn't get any cold influx of water. Pardon me. All right. So, commission of the eddy. There's only a few settings that we really need to be dealing with when it comes to the heat battery. So you set your time and date, and you set in a hot cancel delay as well. So what the hot cancel delay does, if you remember before when I was talking about that soft overheat, the element can cycle off and back on again until the heat starts to circulate within the battery. It'll stay on constantly. On its off cycle with an eddy, the eddy will come up with a maximum temperature reached display. What the hot cancel delay does is it ignores that message for up to an hour. So that's, yeah, set it. I mean, if for up to the 150, you set for 45 minutes. For the 210s and the 300, I'd set it to the maximum 60 minutes. All right. Any other configurations like wireless or separating the phases, you've really got to consult My Energy for that. Yeah, this isn't our device, it's My Energy's. All right, but we can use any solar diverter if it's rated at 16 amps and it's got an AC modulating output. But the eddy does seem to be a popular solar diverter. The amount of technical support we do for this is unbelievable. But for anything, displays off the eddy or having to wire it wirelessly, you've really got to go to My Energy for that. All right. So obviously, your phone us will help you where we can, but if we sort of hit a bit of a dead end, yeah, you'd have to go to them for that. Yeah, and also set your time boosts for the customer. So if the customer's got an off-peak tariff or whatever, set your off-peak tariff times. Certainly for the winter time anyway. Your hot cancel delay. I think they have changed the display for your eddies. This is the older. This is the older software, I believe, demonstrated by Darth Vader. And that's it. Job done. Oh, don't say that again. All right, so we'll just sort of crack on with the sequence of operation. Has anyone got any questions on what we covered?
There's nothing new in the chat, just someone saying that they always use the dynamic heating rod control from MyPV, but the Eddie's also good.
Yeah, that's it. You don't have to use the Eddie. The Eddie's got quite a lot of functionality about it. I mean, again, as I say, 16 amp rated AC modulating output. I mean, I kind of describe the Eddie as a fancy timer to people, because that's, to me, that's what it is. There's more functionality than a timer, but we don't really need all that functionality. But it's there if you want it. So, sequence operation. So you turn on for the first time, your heat exchanger's pressurised, your temperature sensors detect a demand for heat by means of resistance. So that temperature sensor, you've got 3 NTCs in there, negative temperature coefficient sensors. So resistance will be higher. So the PCB reads the resistance of the sensors and energizes the relay. Power sent through the relay to the element via an overheat stat, which is down here, wired in series to the element. So if there was any overheating issues, the overheat stat trips and it stops supplying power to the element. The element comes on, heats PCM up to temperature, sensor resistances change due to the heat being generated. Once the set points have been met from the sensor, PCB stops sending power to the element, or it de-energizes the element really, more to the point. With the heat battery fully charged, the initial outlet of the hot water will be 70 to 75 degrees. Hence your TMV requirement. Your soft overheat, there's 3 sensors in the sensor string. The bottom sensor will read the temperature first due to being closest to the element. This stops the heat battery from overheating and allows the base of the battery to cool. Once the battery has cooled enough, the element activates once again. So once the heat starts to circulate around, then that bottom sensor, what we call TS1, temperature sensor 1, it doesn't exceed its maximum temperature. All right. So with no external timer, so what you'll notice here is LED D5. So you turn on, you've got your power, elements on, elements active. What you'll also get when you get a demand is LED D5 will be illuminated. And that will then energize your DC coil here. All right, so that'll be 12 volts DC coming out here, which will energize your coil. So notice here, that's your power coming in, obviously up to here, powering up the PCB. But we're also linking that power across to L2 here, and that's going to this connection here of your relay. So if you energize that relay, it's going to close the contact, which means it's going to send power down to your element. All right.
Someone's just asking, can you explain the purpose of the hot cancel delay again when you get a second?
Yeah, sure. So what I'll leave this with you now, just so you can sort of familiarise yourself with the flow of what the electricity in the sequence operation. So, excuse me, 2 seconds. this history, electricity starts to flow to your element. You break that contact, you've still got a demand, but the element relay is de-energized. And that's how that works there. So with your PV key, obviously you'd set your key, permanent live coming here, powering up your PCB. There's always going to be a demand for PV, because the reason for that is we want to try and utilize as much PV as possible. All right. And that's not to, everything, LEDs illuminated here. There's a demand. The element really is energized, but there's no electricity going down to your element, is there? Because we've got nothing coming down the modulating live, the L2. All right, so that's quite an important thing to sort of pass over to your customers, because the first thing they'll say is, "Oh, my element LED is always illuminated. It's using electricity." It's not. It's just that's the unit making itself available when PV becomes available, because when it does, the rest is history. That circuitry is already energized for the allowance of PV coming down your L2. So when you're talking about your hot cancel delay, so if you have a hot cancel delay, if you've got a soft overheat, so it's all related to the soft overheat. So if that bottom sensor reaches temperature, what it'll do is it will de-energize your element relay. You still want power to be going down to the relay, but you don't want the eddy to come up with that maximum temperature reached display. So that's what the hot cancel delay does. It ignores that message and it keeps supplying power for that circuitry to then be energized again. And then we hit that soft overheat. We're still supplying power until the heat starts to circulate around the battery, and then it'll stay on. All right, so after about 40 minutes to 60 minutes, that's when the heat starts to circulate, all right?
Okay, so John, who's asked that question, has just said, we're doing the timer via a smart relay which supplies 230 volts to the coil of an additional relay in the eddy, which provides the no volt contacts.
Is that the relay sensor board?
I'll just see if John can put that in the chat.
Yeah, it'll just be a different way. This is the basic configuration. Your relay sensor board will go up here, which has got the relay 1, relay 2, I think the EcoSense connections as well. John
says yes, that is a relay sensor board.
Yeah, so it's just a different way. So you would wire that. If you're producing PV, you could essentially just keep your 3-core. So your fixed 3-core flexors would just go into your incoming supply. You wouldn't remove the links. So it'd be wired like a grid electric model, but your relay sensor board would have to be wired into 1 and 2. Relay 1 would have to go into 1 and 2. And that would make and break the element control circuit. And if when that's made, we know that the eddy is diverting, and you're going to be pulling from the consumer unit anyway, aren't you? Did John give us a thumbs up? I can't see.
Not yet. We do have another question though. It's a bit of a longer one. So, has anyone fitted a unit as well as a combination boiler where the dead legs are very long, for example, a new extension, and used the boiler hot to supply the Sunamp with a temperature sensor to cut off the Sunamp when the inlet temperature hits, say, 60 degrees? And could this additional hot water over the 40-degree blended outlet temperature then be reused to charge the unit instead of electric?
Well, I would say that if you can maybe send that as a technical inquiry into us, and just get all your kind of bullet points written down, and we can have a look at it and review it and let you know. I mean, any dead legs you're looking to kind of get rid of anyway in a system due to Legionella. So, without reading the question fully, that's the only thing I can really answer. But sending your inquiry to info@sunamp.com, and then we can have a look at it and get back to you. All right.
Have a chat about it. Great. And John said that's how we've done it. The smart relay allows the customer to set charging times from an app.
Yeah, absolutely fine. Fine to do that. Good stuff. So that was your basic sequence operation. So there's not much to it. I should really include that sensor relay in there, but I don't want to sort of muddy the waters. If you know about the sensor relay, you're well up to speed with how the eddy works, John. So we'll keep it simple for now. Basic equipment. So pressure gauge for checking incoming mains water, foot pump for checking expansion vessel, digital thermometer for commissioning your TMV. Flow cup for checking your flow rates, multimeter for voltages and resistances, and a 3mm Allen key for removing the screws. So there's not a lot to it when you're working on it. So your temperature sensor, it's of an NTC type, which gives you a resistance reading in ohms. As the battery heats, the sensors detect the heat, and then that resistance value lowers. So when the battery's cool, we'll have across the three sensors, we'll have about 12 kiloohms. Bottom sensor, middle sensor, top sensor. All right, and each sensor has to be the same height as the battery. So if you ever have a problem, I mean, a temperature sensor can, if a wire comes loose or something, it shouldn't do really, but if anything ever happens to it, then you have to make sure you get the correct sensor for that size battery. So we still use the old money when it comes to the labeling, so that's why we talk about the 3, 6, 9 and 12. So in this case, a unique 6 would be a Thermino 150. All right. Sure the correct size is fitted as per the battery. So if it was too long, it wouldn't overheat, it just would never reach temperature. If it's too short, it would overheat. So that's why it's important. So you've got T1, T2, T3. So that's your bottom, your middle, and your top sensor. So how to check them? Set your multimeter to resistance, and by using the yellow sensor wire as a comment, you check across the yellow to blue, yellow to red, yellow to green. And if we go back a few, so if you see up here, that's your sensor wire connections up here, green there. So your yellow, blue's your bottom, red's your middle, and green's your top. All right. So that's, if you don't have a current clamp or anything to check, this is all part of your commissioning. If you don't have a current clamp to check the amps that you're pulling, what you could do is you could take a resistance value reading from yellow to blue, yellow to red, yellow to green, before you power up, and do whatever you need to do, tidy up your paperwork, and just before you put the lid back on, turn the power off again, and take another resistance reading across your sensor. At least then you know that the thing's charging up, and you can have it, especially if it's your first one, you can hand that information over to the customer. But yeah, once you're up to temperature, you should be about 1.5 kiloohms on the blue, 1.6, 1.7 on the red, and 1.7, 1.8 on the green. All right. How do you check it? This is just a temperature sensor sitting out of a heat battery, but yellow to blue, 8 kiloohms. Yellow to red, same. Yellow to green. Does anyone want to tell me what they think the resistance reading is going to be for this? The same, exact same. So that's because it was sitting out of a battery in an ambient condition. All right, that's your sensor wire. So the element relay and overheat stat check. So all new units should be, well, they will be sent with this black relay. It's a DC relay, all right? So that's quite important when you're coming across, if you ever come across a relay that's maybe failed out in the field, it may have an AC relay fitted to it. So if you ever phone us, yeah, well, obviously we'll talk about that over the phone call, but checking the coil of the element relay, you should be about 85 ohms going across that coil. 85, 86. There's one of the white relays there actually. Checking the contacts of it. With the power off, you should be getting an open circuit. So the check that can anybody tell me why you might be checking the contacts of the relay? What could be the fault that the customer's experiencing? It'd all be to do with temperature. It may be an intermittent fault as well.
Someone's saying high energy usage?
Not quite, but you're kind of on the same lines there. So like, yeah, what would happen would be the overheat stat would be tripping because the contacts would be closed constantly. We would be surpassing that soft overheat temperature, and then the overheat stat would be your kind of last line of defence and trip, and that's what would happen. So you should get open circuit with that. But what you can also get, you can get a form of resistance going through that, and that can sometimes be enough to allow the flow of electricity. And it's better to do this check after the relay's been energized for a while, because that can be when the relay contactor can stick, and that's the best time to check it. If it's cold, it will more than likely reset back to open again. But that's what you do there. That's your overheat stat there. So there's your temperature range. So it trips at 96 degrees, and then it'll reset at 90. So if you're getting a constant tripping, then the relay would be my first port of call. If the battery's been in for a while, that is. So, but that's a little cross button there. If anybody ever worked on an older Worcester boiler, an old rank overheat stat, that's what that is. This was made by Schneider. Terrible name for a company, as far as I'm concerned. But if it does trip, the little button, the little crossy button will pop out from the round housing. You can check it by removing these two screws and just checking across the contacts there. Can anybody tell me what you should be getting across the contacts? Would it be an overheat stat wired in series to the element? Any takers, Sarah?
No one's fast enough.
Do you want to have a crack at
it? Someone said closed.
Yeah, exactly. You're looking for continuity through it, across it. So even if you're getting a high resistance, you may have had an intermittent fault and it's tripping overheat stat. If you get a form of resistance going through there, it might not work properly. Should be giving continuity. You can check the element as well, the element circuit. So that's if you can get your probes into the contacts of the relay, the the output terminals of the relay. So if we go back a few slides, where are we? So the output terminals in this here would be these two relay terminals here. All right. Yeah, resistance reading across the element live and neutral. You're also checking your overheat stat here as well. So about 20 ohms, 18 ohms. I mean, that's the plus the resistance of my leads, but between 18 and 21 ohms is kind of what we're looking for. 22 ohms, something like that. So if you get an overheat stat tripped, that's going to be your LED scenario. Power, element, nothing's happening. The customer's got no hot water. Excuse me. Pardon me. So overheat stats tripped, check the button, push it back in. You'll start to, initially, you will hear some, it sounds like you're walking in fresh snow. That's the PCM starting to absorb the heat. Check the sensor, where it's located. So this is quite important on the commissioning, because when you're mucking about the pipes and you're putting insulation in and out and all that, different sparkies, plumbers coming and going, just make sure it's pushed fully home there. All right, because if that's pulled out even a couple of millimeters, that can cause intermittent overheating. If it's pulled out by that much, yeah, it's going to trip out. I mean, I've had jobs where that's been pulled out completely and it's not inserted at all. So, but you can see there that white band can actually move, can slide up and down as well. But that's your gauge. See where so it's a thin wire, looking wire, and it hits the white band to this sort of more bulbous part of the cable. That's where you kind of need to be for it. So there's a bulbous part, but you do get a satisfied feeling when you're kind of pushing it fully home. It can't go any further. You do kind of recognise that. So if you're fitting a timer, remove the link. Believe it or not, we've had that fault from an installation from out in the field. So just remove the link, because that's going to prioritize the over the timer timing. So there's not much really to. Yeah, we've got the two LEDs, the temperature LEDs in the middle here. Yeah, when you're fully charged, the element LED goes off. You get 3 green lights. Happy days. But the two middle ones will pulse depending on what the temperature is inside the battery. The big thing to remember is this is your ePlus with charging from grid. Your element LED will become activated once you've depleted your 20% of charge. Your ePlus is 5%. So yeah, and because you may get this sequence of operation here. So you may get this scenario here. So you're depleting. You may get the flashing 50%. Then the element LED will be illuminated. And then what the customer says, it does this, and then when the PV comes in, it charges up for 10 minutes, and it goes back to 3 green lights again. That's just a normal operation. It's normal functionality. All right. But that's just something to be aware of. And that's it. Has anyone got any questions or any bits of the slides that we want to go over again?